Okay, let's go over homework 1.6, number 8. All right, so part A, we need to simplify tangent of arc secant of 9. All right, again, since we don't like arc secant, so I'm going to try to replace it by, I'm going to just call it, let theta to be arc secant of 9. All right, how about that? Right, so what we're looking for is now a little simplified. It's we're looking for tangent of theta. All right. All right, so just like before, we want to deal with the regular trig function instead of inverse trig function. So I'm gonna rewrite this guy using secant. So this is gonna be a secant of theta is equal to 9, right? All right, then what we're going to do is we're going to try to draw a right triangle using this information right here. Secant of theta is equal to 9. And remember that the secant of theta is a reciprocal of cosine, and a cosine is adjacent over hypotenuse. So its reciprocal would be hypotenuse over adjacent. All right. So we know that the hypotenuse over adjacent would be 9. So we can set h to be 9 and adjacent to be, say, 1, right? So then you try to draw a triangle. So it's going to be a triangle which looks kind of like this, right? So it's going to be a triangle, right? And a right triangle, I should say. And this is angle theta. So adjacent is 1. So this is 1. And hypotenuse is 9. Right? Then you can find this by using Pythagorean theorem. Sorry, I should say. So this is going to be a square root of, right? 9 squared would be 81 minus 1 squared would be 1. Right? So that's square root of 80. Right? So you have the square root of 80. All right. Then we just need to find the tangent of theta. So here, this theta is actually exactly the same thing as this theta. Right? So tangent of theta, by definition, is opposite over adjacent, right? So opposite is square root of 80 according to this right triangle, and adjacent is 1, right? So therefore, that's a square root of 80, right? So answer would be square root of 80, right? I mean, you can rewrite square root of 80, but I'll probably, the system should take that. If not, let me know. All right. For part B, the trick is pretty much the same way. So we're going to do a substitution. So I'm going to say let theta to be arc sine of 3 over 5, right? So we can rewrite this guy as sine of 2 theta, right? But the sine of 2 theta, we can rewrite this guy as, using a trig identity, it's the same thing as 2 times sine of theta times cosine of theta, right? So we need to find sine of theta and cosine of theta, then we're home. All right, so first we're going to rewrite this guy using just a regular sine. So sine of theta is equal to 3 over 5. All right. So we already know now, actually, we can say this, all right? So no, this is separate, all right? So this is 2 times, all right? So sine of theta, we already know it's 3 over 5, all right? Then cosine of theta, we can find out by looking at it. So sine of theta is adjacent over, actually, sorry, opposite. I meant opposite over hypotenuse, right? So we can take opposite to be 3 and the hypotenuse to be 5, right? So now we have a triangle which looks like this. So right triangle again, and like that. So it's a right triangle, right? And this is the angle theta, right? Opposite is now 3, right? And hypotenuse is 5, right? So adjacent is going to be square root of 5 squared would be 25, minus 3 squared would be 9, which is square root of 16, which is 4. All right. So we can find the cosine of theta because cosine of theta, by definition, adjacent over hypotenuse. So adjacent is going to be 4. We just found that. And the hypotenuse is 5. Right? So cosine here is 4 over 5. Right? Then we can just multiply all out. You're going to get, let's see, 2 times 3 would be 6. 6 times 4 is 24. And over, and 55, sorry, not 55, 5 times 5 is 25. Right? So therefore, the value of this is 24 over 25. Right? That's it. I hope that this was clear.